Hi, so I'm Josh Kaplan. I'm a senior program manager with Microsoft. I'm on the Azure Analysis Services product. Before we begin this apparently untitled session, do a quick little quiz. This will help me actually kind of level set and know where to kind of guide the content. Do a quick quiz on just BI data or BI tools. Can you just raise your hand if you actually use, let's say, this tool to start with? So this one's Power BI. How many people are familiar with what this tool is? Or have used it? This one's Tableau. And the last one's a little obscure. Not many people here I'm expecting to have used it, but how many people have used this one? All right, so Excel, usually everyone. So what do these all have in common? And one of the things they have in common is they can all talk to Azure Analysis Services or Analysis Services. So what is Analysis Services? Think of it as your facilitator, your lens, the thing that gives access to your business users to be able to access the data that's within your application or the data that's within your business. It provides the data modeling pieces, security pieces, and a very fast in-memory cache to make that data kind of fly. And it connects up to a whole bunch of different sources. Here are just some of them. Now, the three tools I showed before can all directly connect to these sources as well. But let's look at one of the reasons why you would want to put analysis services kind of in between your users and the data directly. One is this rich semantic modeling. What the semantic model is, it's kind of like a lens that your users look through. These could be business users who are very good with the data, but maybe not super technical. You can keep the data, you can make it available to them, but you can give them kind of this view they look through that kind of expresses it in business-friendly terms, business-friendly language, gives them kind of an easy drag-and-drop ability to go and query that data. Essentially, it turns all that data that you have that's locked away in data warehouses, in tables, turn it into something that a business user can go and consume. For example, if you're using Power BI and you're connecting directly to, let's say, a SQL data warehouse, you would essentially, when you connect, you get a list of tables. Those tables may or may not have friendly names. A lot of times, the data warehouse is optimized for different things other than business users querying it. And they'd have to go through and find out which tables they kind of need to get their data from. They'd go ahead, they select it, and then they get literally a bunch of tables back. You then have to figure out how is the data between these tables related. What columns do I join on? What tables can be joined together? And finally, the actual business logic. They'd have to come up with how are certain metrics calculated. I've been in meetings before where two people come in with the same metric, like something like revenue to date or week over week, and they're presenting the same metric, but they have two different numbers because they calculated it two different ways. This is something that if you give someone access directly to the raw data, they have to kind of come up with and put together themselves. So with analysis services, you can bake all that data into a semantic model. You can see here all the relationships are there. You can put all your calculations in there. All your business logic can go in here. And this gives someone a starting point to work from to go out and build their own reports. It lets you connect all three of these tools up here. You get access to that semantic model, and then all three of these will let you just drag and drop and start building out any reports you want. And I'll show a demo of this in a moment. In addition to the semantic model, Analysis Services provides one other really big value, and that is it can give you lightning-fast queries. We have a very fast in-memory cache. It's column store indexed, but it's 100% in-memory when you load your data into it. And it lets you kind of just fly across that. Better just show it than actually talk about it. But one reason that that's so important, if you look at Power BI, you look at Tableau, you look at Excel, your users are not just executing one query. Like this report here has 1, 2, 3, 4 visuals on it. Each one of these fires at least one query. So every time someone drags something on here, interacts, it's firing off multiple queries against your database. That puts a lot of load on your database. And also, it has to return very fast for a user to actually get a good experience here. So the slower it is, the kind of the worse this exploration experience is. It's a very demanding experience. So let's actually take a look at that. I'm connected up here in Power BI already. Essentially, you give your users a server name, they go ahead and connect, and then this is what they'll see when they log in. They'll see the data model already created for them. And this data model actually happens to be on top of a bunch of data that we collected from New York City taxi cabs. So all the trip data, like where people were picked up, how long the ride was, how much the fare was. And we collected that all into a data warehouse. And then we built this model on top of it so we could build reports on top of it. And we've also cached that data. So let's imagine we were thinking of starting a new career and becoming Uber drivers or taxi drivers. And we wanted to see, is that a good thing to do? If I'm in New York, am I going to make some money doing that? Let's look and see how many trips are there in New York in the time period we took this data from. So I can just come to my trip table, and I can just find a trip count measure and just drag it on here. And what that's going to do, if I have internet, there we go, is it's going to actually go and calculate the number of trips in that data set. And what it really did is actually sent out a query from my laptop up to Azure. And the logic for determining the number of trips is just to count the rows in the trip count table. So it counted that and returned it. It basically scanned just over 2 billion rows in that second where I pulled that on there. So yeah, there are a lot of trips in New York. You can definitely, as a cab driver, pick up some people. But where are the best places to go and make some money there? So let's look at where all the trips are happening from. Every time I'm clicking here, we're going to be round-tripping back to Azure Analysis Services and running query across that cached data. So we just plotted all those 2 billion rows onto a map here. And it's New York, lots of trips. They're kind of everywhere. So the map just confirms there's lots of trips. But let's see, where's the most popular place to pick people up? Let's go ahead and grab our revenue per trip on here. This is the average revenue. Me, as the user building the report, I don't have to know how this is calculated. I can just grab it, drag it, and drop it on here. And let's say I want to see where are the top pickup locations. Well, there's a top pickup location dimension here. I can just grab those zip codes, drop it on here. Again, it's running queries and replotting that. And we see there's two big zip codes that really stand out in New York. Any guesses to what those might be? JFK and LaGuardia. Well, if we didn't know, we can just click on it. And when I click on it, it's going to fire off a query for here and a query for here to just show the rows that are in this bar. And we'll do that. And yep, first one is JFK. And the second one is LaGuardia. LaGuardia, apparently there's long lines all the way up the highway to get a cab. But you can see, so it filters down this visual and it filters down the row count here. We're at 41 million rows, or 41 million trips for LaGuardia, which equals also 41 million rows. So it looks like here that I can make a little bit more money per trip if I pick up people at JFK. It's a little bit more than LaGuardia. But let's see, where can I get the most trips from? So let's actually take our trip count measure and put it back on here. We'll create another set of queries. And then let's throw on here our average trip duration. And let me make a little room for it. Now, Power BI has this feature when you click on something, it kind of cross-highlights down everything else. So if I click on here, it shows me just the values for there, but it also shows me the percentage of total those values are, which is kind of not ideal here because there's such a low percentage of the total. So you can actually change the way the visuals interact in Power BI. If you go into your visual interactions, and basically I can say this one should filter this one instead of cross-highlighting it. And now when I click on here, I'll just see the trips for this bar, not the percentage of total. And you can see that the majority of the trips from JFK are 30 to 45 minutes in length. There's some 15 to 30 in there. But when we look in LaGuardia, the vast number of trips are in the 15-minute range. So while I can make a little bit more money per trip at JFK, I can potentially get more trips by going to LaGuardia and picking people up there. This is just an example of how when the data's still big, but when it's that fast, you can come in and just interact with it, ask questions of it, make mistakes, notice those mistakes, redo them. And we're picking up the business logic that the modeler created and put in here for us. So anyone using this model to create their own reports, if they're using trip count, if they're using revenue per trip, they're going to come back with the same metric, but different reports, potentially. So this is the architecture of that demo I just showed. We collected the data into a SQL data warehouse, and then in between Power BI and that data warehouse, you put Azure Analysis Services. And we put a very high-level aggregate, but still 2 billion rows of full data we put into that Azure Analysis Services model. On top of that data, you can apply things like security, like certain users can only see certain data. The model will handle applying that for you if you put that into the business logic. Taxis are doing rides every day, so new data is constantly coming in, constantly changing. So we have to keep that data up to date if we want to keep it cached. There are lots of ways of doing it. I'll show you an example excuse me, in the end, where we actually used Azure Functions as a way of recognizing there's new data there, creating new partitions into our model, and then processing those partitions to get the new data available. This is another architecture that we see as common. It's just another example of an end-to-end where you're kind of capturing the data, you're ingesting it, you're sanitizing it maybe in HDI, and you're storing it for long-term storage in your data warehouse. But then for consumption, you're going to cache it into analysis services for Power BI and other tools to go ahead and interact with it. The common thing we see with people is also that they have multiple caches. They might have subject area specific caches. Maybe they have one for the sales team, they have one for the finance team. That way they get a business-oriented view, and they get the data that's specific to them. But real briefly, to build one of these models, we're service in Azure, so you go to Azure portal, you can go and create your own server there under Azure Analysis Services. And then you would open up Visual Studio to actually go ahead and start building out the model. This is the same model for that taxi cab demo in here. And you can see all the relationships are in there. The reason I could drag and drop in Power BI and get results is because all the relationships are in here. So the user doesn't have to know that. The modeler kind of gives that to you. And you can see that the tables aren't exactly like data warehouse tables. They have friendly names on them. There's spaces and there's descriptions on there if you actually look at the description property. It's written in terms that the business user would understand. And you don't have to physically change your data in your data warehouse to do this. And we also have our calculations in here. We flip over to a different view. Like the revenue per mile. It's a pretty simple calculation. It's just a safe divide of revenue divided by the the total distance in miles. But they can be anything from really simple things to really complicated things. This is our DAX query language. And you can do all kinds of really cool stuff in here. Time shifting is a really cool functionality you can do. If I want to look at periods to date, or I want to look at period over period, there's a lot of functions that make that really easy for you to enable in here. One other thing we have in Visual Studio is you actually have, this was pretty big data and it's constantly loading in. So you have the ability on your tables to partition them. Oops, those are our security roles. Those are our tables. And you usually want to partition only the big tables, something like date, something like the licenses. It wouldn't be that big, so you don't really need to partition. But trip, where all our trip data was, that 2 billion row table, it's a good idea to have some partitions in there. Partitions let you do a few things. One is it lets you incrementally load the data without changing what's in what's already been processed. In addition to incrementally loading, it lets you also drop off old data if you want to. And it also parallelizes your load a little bit more, too. So each partition has its own partition query that queries your data source and pulls in only, in this case, it's pulling in just a specific date ID for that partition. And if you have multiple partitions, you can run multiple processings in parallel, and it'll pull more data in kind of more quickly. But this will let you actually kind of scale and grow your solution into something as big as what I was showing, or even bigger. One last thing to show in here Yes. This is the Visual Designer, but if I go to Solution Explorer, this is the Visual Studio project. I can always check this in. I can version it along with my code, my database code, my report code. But also, we have a code view in here as well. So everything you see in the UI can also be done through code, our .NET library, and our JSON scripts. So this is our model definition. Model name has an array of tables. Tables have columns. And all this can be done programmatically or manually. And nice thing about this script view, too, is if you have multiple people working on the same model, you check it in. You can now do diffs between what was checked in and what's there, and you can do code reviews and just see what's changed, which is something nice that it's relatively new to SQL. We released it about a year ago, this functionality. So that's a good segue to just talk about what you can code with analysis services. We have 2 query languages, MDX, multidimensional expressions. That's what Excel and Tableau use to actually go ahead and query the data in there. We also have another query language called DAX. That's what I was showing those formulas were written in. It's also what the Power BI UI uses anytime someone's dragging to actually generate queries. DAX is kind of the newer one. Then we also have APIs that will let you manage and create servers and models. So MSOLAP, ADOMD, they're all our drivers, our connectors. That's what the client tools I was showing you use to actually connect and talk to analysis services. Then we have AMO and TOM. Those are our object models. We have a .NET object model that lets you automate everything from creation of the model to partitioning to processing to everything in there. And you can do that through AMO. You can do that through our scripting language, tabular model scripting language. You can do it through PowerShell, and of course, since it's a Azure service, you can do it through ARM as well. This is the tabular object model. It has everything I was showing you there. Has an object in there that you can do. You can manipulate or create programmatically. And this is an Azure function I wrote that does processing of the server. So when new data comes in, function gets triggered, and it basically connects to the server, finds the database that's on there, finds the model that's on there, and just calls refresh on it. This example is actually up online. There's a link to it in the slides. I'll make it available. But if you go to the Azure blog and you search for business, and you click on business intelligence, you'll see the blog for automated partition processing. And there's actually a white paper that goes along with that that gives you, shows you how to actually do like rolling window loads, basically all different kinds of ways to load your data into analysis services and do it through Azure Functions or do it through other forms of automation. A couple links here to learn more. I want to save a little bit of time. I have about 3 minutes left if there's any questions. No questions? So SQL Server has shipped with analysis services for about 2 decades now, almost. This is now a full Azure service for analysis services. So without SQL Server, you can go and in Azure create these servers and have them hosted as a PaaS service in Azure. So you don't have to manage the server, you don't have to manage the OS. It's all kind of managed for you. Say again, sorry? Is there any limitations in the feature set compared to the SQL Server version? Pretty much no. We made sure the APIs, the surface area was the same. We only have tabular in Azure right now. And for the most part, the APIs are identical. There's a couple of little things you can't do, like we don't have server sync or we don't have server sync at the moment. But you can back up, restore. Everything else is there. It's just little things you could do when you actually own the OS are not there because you don't own the OS anymore. Say again? Manage the dimensions? Oh, many-to-many. Tabular's been able to do many-to-many relationships for a while now. Yep. Work with Power BI embedded. It drop by the Power BI booth for the official word. The last I heard is it works with the Power BI premium offering that's coming in June. so that you will be able to make embedded applications that are leveraging this. And this is kind of one of the best ways to scale one of your embedded applications. You have lots of users, multi-tenant users, lots of data. You can host that here and manage it with all the tools we have. Anything else? Doesn't have to be. Yeah. The question was, do you have to have a star schema relationship? No, doesn't have to be. Can you use Power Query? So Power Query is more for the data ingestion, and as of last week, we announced that we now support the Power Query in Azure Analysis Services for ingesting data. There's no booth for AS specifically. There's the Power BI booth, which will be able to handle both questions. If there's anything specific, I can help too. Thank you. Under what circumstances?